Got a bit of a trigonometry lesson for you right now because we need that in order to solve for those angles of those resultant vectors. Yesterday we were talking about how to solve for the resultant vector. We did a pretty good job of it. We reviewed it earlier today and I think we nailed it. That is finding the magnitude of the resultant vector. But what about the direction? What about the angle? Spent a few minutes talking about that trigonometry, okay, to get us kind of back into that groove. You've all learned this before. It's just a matter of remembering it and applying it. Most of you guys probably remember the little mnemonic device SOHCAHTOA. How many people have heard that before, SOHCAHTOA? Okay, so we say SO, sine is opposite, sine theta is opposite over hypotenuse. CA, cosine theta is equal to adjacent over hypotenuse. And TOA, tan theta, is equal to opposite over adjacent. If we have a triangle, any right angle triangle, let alone a vector diagram right angle triangle, which is always what we're going to have, right? Because that's our goal, to get a right angled triangle vector diagram. We need to know which side of the triangles we're dealing with. So let's say this is my vector diagram. Let's say this side is 20 meters, and let's say this side is 10 meters. We could find the value of r there pretty easily, right? We've done that quite a few times already. Do the Pythagorean theorem. A squared plus b squared is equal to c squared, or r ends up being the square root of 20 squared plus 10 squared. But what about the direction? That's what we haven't done to this point. First thing I got to do is label theta here. Where do you want to find the angle? Position 1, position 2, or position 3? 1, 2, 3. It's position 1. Always find the angle at the start of your vector diagram. Always at the start. Now, let's label these sides. My suggestion for you, if you have any trouble with this, either because you had trouble when you did it in math class, or because you don't really remember it, it's been a while, my suggestion is to always label the hypotenuse first. The hypotenuse is always the longest side. So label that first. Does that make sense? That red one will be the hypotenuse because it's the longest side. Now, usually that ends up being the resultant vector, but later on you're going to see situations where it's not the resultant. The hypotenuse is always, however, the longest side. Now, the next one that I would label is the adjacent side, although it doesn't really matter now. The adjacent side is, the hypotenuse touches the angle, you can see that. The adjacent side also touches the angle. So it's the other one that touches the angle. It's the 20 meters. This would be adjacent. Adjacent means beside. So this 20-meter vector is beside the angle. But it's not the longest side. So the adjacent and the hypotenuse both touch the angle, but the hypotenuse is the long one that touches the angle. The adjacent is the short one that touches the angle. That means the 10 meters is what? 10 meters would be the opposite side. It's the one that's the only side that's not touching the angle. So hypotenuse touches the angle long side, adjacent touches the angle short side, and opposite doesn't touch the angle. Now, I have, and this is always going to be the case, opposite, adjacent, and hypotenuse, you're always going to have two of them. Which two do I have here? Opposite, adjacent, and or hypotenuse. Which two do I have? Opposite and adjacent. Okay, take a look up above here. Which trigonometric function here does it look like I should use if I've got opposite and adjacent? Tan. Right, tan. So if I want to find that angle, I'm going to use tan. Okay, not because of any other reason other than the fact that I have the opposite side and I have the adjacent side. If I had opposite and hypotenuse, I would use cosine now. If I had adjacent, I would use sine, right? Opposite and hypotenuse, I would use sine. If I had adjacent and hypotenuse, I would use cosine. Okay, use whichever trig function goes with the sides that you have. Okay, so tan theta is equal to opposite over adjacent for this one. Now you got to rearrange this to solve for theta. This is different than rearranging any other equation. The other equations, you take over what's not attached. You take over what is attached. Then you start squaring or square rooting or whatever you got to do. Here, to solve for theta, you got to take the tan over by making it an inverse. We call it inverse tan. Tan to the minus 1. Inverse tan of opposite over adjacent. And then I do this. Theta is equal to the inverse tan of 10 meters over 20 meters. I would calculate that angle on my calculator. Everybody do this on your calculator. Everybody take out your calculator right now and do this with me, okay? Before you try to enter this, please do this. Hit on your calculator sine 90. How many people got 1 when they hit sine 90? How many people got 0.89 when they hit sine 90? Okay, if you got 0.89, you're in radian mode, and you don't want to be in radian mode. When your calculator gets cleared on test day next Thursday, it will go back to radian mode. You need to switch it to degree mode. Here's how to switch it to degree mode. I'm already in degree mode because I got sine 90 is equal to 1. Okay? Every time you go to do something on a test or a quiz, you should test that. Hit sine 90. That's our little test, right? If it's equal to 1, you're good. If it's equal to 0.89, you're not good. Here's how to change it if you're in radian mode right now. Click the mode button up here. Scroll down. You can see that my degree is highlighted. If your radian is highlighted, then scroll down, go over to degree, press enter, and then clear it. And then try that again, sine 90. So everybody, if you were in radian mode, go through that procedure and then hit sine 90 again. If it still equals 0.89, then let me know and I'll show you how to do it. All right, let's enter this now. Let's say theta is the second function. See what I did there? Second function, tan. That's what gives me the inverse tan, tan to the minus 1. Second function, that yellow button, I think on the 84s it's a blue button, I think, isn't it? Okay. Who's got the 84 or the CE? Yeah, just the 84s is a blue button. I think on the 83s it's a yellow button. Who's got the 83s? Ben, you get an 83? 83 plus? You have an 83? Yeah. It's a yellow button, right? Yeah. Okay. So the inverse tan of, we're going to say 10 divided by 20, end the bracket, press enter, and I get 26.6 degrees. There's my angle, but we're not quite done. Okay, to leave it at that would be the equivalent of saying, instead of saying Mr. Dickie is 2 meters from the front of the room or Mr. Dickie is 6 meters from the back of the room, which is okay, either one, right? That would be the equivalent of saying, oh, Mr. Dickie is 2 meters or Mr. Dickie is 6 meters. If we're going to have a different frame of reference, that's okay, but we need to state what that frame of reference is. So what are we measuring this 26.6 degrees from? I measured my position from the front of the room or from the back of the room. What are we measuring the 26.6 from? From the start, yeah?
It's west, southwest.
Yeah, it's not west, but east, yeah. We're measuring it, look at this. We're measuring it from the east. That's east. We're measuring it from the east. But then we're going down or south from the east. South from east. Okay, does that make sense? South from east. So we're going to label that south of east. 26.6 degrees south of east. Now, if I had have drawn this differently, and I could have, right? I could have drawn this 10 meters this way, 20 meters this way. That would be okay, right? Label theta at the start of my vector diagram right there. If I calculated r would work out to be the same value. What about theta, though? Which side of the triangle is the hypotenuse? 10, 20, or r? R. Which side is the adjacent, my next one? The other one that's touching? 10. Which side is opposite? 20. So we're going to say for this one, theta is equal to the inverse tan of opposite over adjacent. This time the opposite is 20. The adjacent is 10. The inverse tan of 20 over 10. Let's calculate that. Second function, tan, 20 divided by 10 gives me 63.4. Does that make sense? That's right. That's absolutely right. But it's different than the 26.6. Well, just like I'm 6 meters from the back of the room is different than I'm 2 meters from the front of the room. But we have to express a frame of reference here. 63.4 degrees from what? Where am I measuring it from? Am I measuring it from, okay, just bear with me here. Am I measuring it from the north? No. Okay, am I measuring it from the west? No, there's nothing to do with west there. Okay, this one gets a little bit tricky now. Am I measuring it from the east? That's the east. Is the angle touching the east? Then I'm not measuring it from the east. Am I measuring it from the south? Yeah, I'm measuring it from the south. But then where does it go from the south? It goes east from the south, right? Like this is east over here, and it's going east from the south. So we would say this is 63.4 degrees east from south, or east of south. 26.6 south of east, 63.4 degrees east of south. Both are absolutely correct. Got it? So, know your trig functions. For the time being, you're going to be using tan. But every time you see the question, like stop and look at, make sure you know why you're using tan. Okay, make sure you know what your opposite is, your adjacent is. Remember, hypotenuse, first one to identify, because it's the long side. The long side touching the angle. The adjacent is the short side touching the angle. And the opposite is the side not touching the angle. Okay, know which two sides you have, use the right trig function, solve for it, and then look at where you're measuring your angle from. If it's from the south, then it would be something of south. Here's what I want you to do. Those three questions that you had for homework last night that we went over earlier today, I want you to take a look at those and solve for the angles, solve for the directions for all three of them. I'll give you a hint. All three of them are going to use theta is equal to the inverse tan of opposite over adjacent. Which would be my opposite side in this one? No, that's a bad question. I should identify the hypotenuse first, right? Which is the hypotenuse? R, which is the adjacent, the short side touching the angle. 200, which is the opposite? The other 200, the one that's not touching the angle, right? That one we already identified would be 45, but go through that process anyways, right? Okay, let's finish this one off. We said it was the inverse tan of opposite over adjacent. What's the opposite side here? Well, the adjacent side is the one that's touching the angle, but not the longest one, the short one touching. This is adjacent. This one's opposite. So we're going to say it's the inverse tan of, well, it's going to be 200 over 200 in this case, which is just 45 degrees. But what do we express that as? Look, this is, we're going east, right? We're also going south. We're going east and we're going south. Where's the angle measured from? Is the angle measured from the east or from the south? Look at that angle. It's measured from the east, not from the south. It's measured from the east. So we're going to say that south from east. Or let's replace the word from with of. Yeah, it's going to be south of east. So we got 282 meters at 45 degrees south of east. Now in this case, because it's 45, how'd you drawn it this way? You would have also gotten 45 degrees, and that would have been east of south. Yeah, Rachel? Sorry, west. Yeah, sorry. South and west, south of west. Yes, thank you. Sorry about that. Good? Okay, let's take a look at the next one that we had. There's our triangle over here. We already have the angle labeled. It's at the start of the diagram. Okay, always where it's tail to tail, start of the diagram. We're going to say, well, what do we got here? This R is which side of the triangle? Opposite, adjacent, or hypotenuse? The longest side is the hypotenuse. Good. This other one, the short one touching, is the adjacent. Okay, and the long one or the short one that's not touching is the opposite. We have opposite and adjacent. Which trig function do we want to use there? Tan. Opposite and adjacent. We're going to say theta is the inverse tan of opposite over adjacent, 30 over 10. What do we end up getting for that? Here, I'll do this on the calculator here. We're going to say the inverse tan, second function tan, of 30 divided by 10 gives me 71.6 degrees. And what is that? We're measuring it, look, we got east and we got north. East and north. Are we measuring that angle, ladies, girls, from the north or from the east? From the east. North from east, or we're going to say north of east. 31.6 degrees north of east. Sorry, 71.6 degrees north of east. Finally, the last one here. Okay, I've got it drawn two ways here. That's okay. I'm going to solve it both ways because you guys probably picked one or the other. It doesn't really matter which one. I'll solve it both ways here. First way, over here. Okay, R, this one is which side of the triangle is that? That's the hypotenuse. The longest side is the hypotenuse. The long side touching the angle is hypotenuse. The short side touching the angle is the opposite or adjacent. Adjacent, and I have that side. And then the other side not touching is the opposite, right? So the short side touching is adjacent. The short side not touching is opposite. I'm going to solve for theta using the inverse tan function of opposite over adjacent. The opposite side was 20. The adjacent side was 10. Let's solve that. The inverse tan, the second function tan of 20 divided by 10 is 63.4 degrees. What of what? Well, I'm going west, right? And I'm going north. West and north. Where am I measuring my angle from? West or north? West. So it's north from west or north of west. 63.4 degrees north of west. Okay, let's do the other one here. Theta is equal to the inverse tan of opposite over adjacent. What's the opposite side here? 10. The adjacent side is 20. Remember, adjacent is the short one touching the angle. The opposite is the short one not touching the angle. The inverse tan of 10 over 20, that's going to give me, I'm going to do a lightning fast calculation in my head on this one. That one's going to give me 26.6 degrees. 26.6 degrees. How do you think I got that? Yeah, I just subtracted 63.4 from 90, right? 26.6 degrees what of what? I went north and I went west. Where's the angle measured from? From the north. From the north. So it's west from north or west. Whoops, not west of west. That doesn't make any sense. West of north. Make sense? Okay, I'm going to give you one problem to work on, not on your worksheet, one problem to work on for homework tonight. Just one. Copy this down, please. I got 200 meters to the east plus 400 meters to the south plus 300 meters to the east plus 100 meters to the north plus 150 meters to the west. I want you to add those vectors together, find the sum of those vectors, add them together, find the resultant vector. Those all mean the same thing. And now, for you, those all include a magnitude and direction, because you know how to find that angle and what it's relative to now.